Thank you, Firas. Hello, my name is Muhammad Shafiq Rashaidi bin Muhammad Uzi, Head of Gear, Body and Seat Department. Generally, there are three major components that play a significant role in this department. To keep things running smoothly, I decided to divide our department members into three teams. With this, they will simply concentrate and provide their whole dedication on their part. During this semester, we have improvised the design, make simulation analysis and plan to fabricate our parts. Even the gear team has already purchased the component required for fabrication and also surveyed the available workshop nearby to use the machinery. Fortunately, last couple of weeks, our government have announced total lockdown. This is horrible news for us. However, we must follow the government SOP guideline to flatten the curve of COVID-19 cases. So, we decided to make 100% simulation analysis to complete our parts. Without further ado, let me begin this department presentation with Seat Team. To you, Adele.
Thank you very much, my fellow head of department, Shafiq. First and foremost, I would like to introduce myself. Hi, I'm Afdal, the resource person for Team C. Before we are going deeper in our finalized design and simulation for the seat, let us recap a bit on our process from the beginning. Generally, we started our design on seat by researching what can we improve from normal seat as in the market, and we think we found it. The most suitable and simplest seat is the recumbent style. As our objective on achieving the 4 sustainable development goals, this kind of seat exhibit a more relaxing way that the user, especially student, can sit on the accelerator. Then a few adjustments are made into the seat, such as armrest, longer back seat, and adjustable height. Next, we jump into the materials chosen. For the frame, we choose rectangular hollow steel, same as the body frame. This allows easier joining process between those two parts. At the same time, we used memory foam as the cushion and PVC leather to cover the seat. On top of that, we use high quality spray paint to cover the frame part. All of these materials chosen are the most suitable, and after we brainstorming each of this part. Finally, after we have reached the final design, we proceed with the simulation. This simulation is divided into 2 parts. The first part is with stress bond pieces, which analyzes the durability and strength of the seat frame when subjected to load. In this analysis, we use a load of 800 Newton down on the vertical axis and 500 Newton on the horizontal axis. This is to be assumed the weight of the person who will be sitting on the seat and leaning on the horizontal axis while pedaling. Second analysis are more on human analysis. It analyzes the suitability of human height compared to XLR8. This seat can be adjusted on the frame according to human height. For this simulation, we categorize into 3 adjustment positions. Namely, at the first position of a human being 1.5 meter or 1500 millimeter tall. Next, the human is 1.7 millimeter tall and 1.9 meter tall. Alright, that is all from Team C. Back to you, Shafiq.
Thank you, Adele, for your explanation. Seat will make user feel more comfortable during experience our goods. However, body also play an important part in having enough strength to support user weight. So let us hear the explanation from Elisa. To you, Elisa.
Hello, my name is Elisa, the team leader for body frame, and I will be explaining body parts in this project. Since we know that all things in this world may have main part for each object that exists, so body is the main thing in this project. Why is it important? Let us have a look. The body of XLR8 plays a significant role in supporting all components for all departments. The fundamental aim of a sturdy and solid body frame is to keep the people who use it safe. So, how can we ensure that people can use the body frame safely? It is not as easy as you assume. We perform a lot of study on the design, material use, and the type of support. and we also go through every single detail thing that you might never think about. We desire the highest quality for all of our users' needs. That is why we only want the best. Because of the properties of the material and the strength of the joining, we choose mild steel and gas metal outwelding as the primary joining. Instead of using mild steel for the whole body frame, we use aluminium for some parts to reduce the weight. In order to prevent corrosion, we also utilize high-quality spray paint for the finishing. And acrylic sheet was used as the cover for the gearing system. Besides, those metal materials are permanent material that can infinitely be recyclable with no quality degradation. That meets the main purpose of sustainable development goals. The body frame was designed to be user-friendly and was set to the suitable length and height so that users generally range from different age group could use it. Since our target are from elementary until high educational level, we make sure XLR8 is suitable and practical. We will ensure that our users understand the objective of our innovation, which is learning tools as our goal. So, how does the XLR8 body assist to our targets? Our critical role is to ensure that the students can observe the gearing system changing. We cover the gearing system with a see-through acrylic sheet so that students may easily understand and experience gear shifting and energy conversions. For maintenance, the acrylic sheet may also be opened. Since we have an obstacle in doing this physically due to this pandemic, we did our best to demonstrate that the design we created was well suited to our purposes. We use CATIA simulations to determine the best decision for our users. This is the first body design that we did, and let us proceed to the simulations.
So we can see there is a deformation happen in this body frame after applying 80 kg weight in factor 1 condition. Next is von Mises stress. Yielding might be happen in real situation. We can clearly see the translational displacement effect on the body frame after force applied. We know that we need to enhance after running the test to overcome this problem. This is one of the design we created to upgrade. However, after taking into account the cost, the material utilized, and the weight, we did not consider it was the ideal design for a body frame. Now, this is the final design we choose as our body frame. Let us take a look at the simulation. So we can see the difference between the first body frame design and the latest one. In real life situation, the factor used in simulation was factor 1. You can barely see the difference happen after force applied compared to the old design.
That is all from me. I pass back to our head of department, Shafiq Rushaidi.
Thank you, Elisa. We have already given our best to accomplish this project, from the tiniest to the biggest detail to ensure user safety. This is always our first priority to assure the safety of this project. Last but not least, for this department, let me introduce you to the heart of the project, which is Gear Team. To you, Amirullah.
Thank you, Shafiq. Hi, I am Amirullah and I am a lead of gear system design for our product XLR8. So now I am going to present and show our product design gear system. To begin with, let us have a look on the gear system configuration. As we can see, the gear system would consist of a sprocket size 38 teeth, 3-speed gear of size 12, 13 and 15, gear shifter, chain and pedaling set. This gearing system part are basically same with bicycle gear system in terms of its component use and its material. Thus, all these components are available at bicycle spare parts store and easily get for the installation. Some might wonder, why does we implement 3-speed gear, right? The relevance of using 3-speed gear is to educate or show the mechanical motion of each gear, precise on its rotation, and how does the gear shifter works to locate the chain between gear size 12, 13 and 15. And this is solid motion simulation of single gear set. Apart of that, it is also aiming to observe the change in the output speed produced of each gear size set. This is gear ratio data of speed gear size 12. As we can see, the output speed ratio is 1:3.17. where one rotation of sprocket size 38 will produce 3.17 rotation of speed gear size 12. This ratio produces the output speed to be 190 rpm for the input speed of 60 rpm. While the gear ratio of sprocket size 13 is 2.92 and for speed gear size 15 is 2.53. The conclusion that can be made from the data, as the gear ratio decreases, the output speed will decrease. How can we do the observation? What is the clear change that we can see actually? In order to portray the clear observation, we implement two output devices, which is photovoltaic and generator. Modification that we did onto the gearing system is the output shaft will rotate at the same speed as the speed gear and will be transferred to water vortex and generator motion. Theoretically, the output speed varies with the gear ratio produced for each gear speed size. The brief explanation on these output devices will be done by the next presenter. I think that is all from me for this part, and I will pass back the presentation to Shafiq. Thank you.
Thank you so much, Amirullah. So, we have three alternative gear size to create different gear ratios, and also to vary the output to be monitored. A few simulations have been run to ensure that the gearing system works flawlessly. So, that's all from us at Department Gear, Body and Seat. I will hand this presentation back to our CEO, Firas.